This is our thermodynamics investigation video. Our group members are Sam Guernsey, London Gardner, and Quentin Gardner. And the purpose of this project was to find the coefficient of convection for a convection oven and a air fryer.
For the setup of this investigation, Mr. Guernsey and Mr. Garner had grabbed 2 russet potatoes roughly 3 inches in diameter. Each potato was placed into a convection oven and then the air fryer. Both air fryer and oven were set to a temperature of 350 degrees. Before the potatoes were placed into the air fryer and oven, they grabbed an internal temp of 65 degrees with the thermocoupler, which is shown in the picture above. What they did to insert the thermocoupler is they poked a small hole and then pushed the thermocoupler in and placed each potato in an air fryer and the oven. Once the potatoes reached a temperature of 210 degrees, they took it out and they measured the time as they started it by placing it in at the beginning and then ended it when the temperature reached 210 degrees on the internal temp of the potato.
The time it took for the russet potato in the convection oven to reach 210 internal temp was 49 minutes and 48 seconds. And from there, we calculated tau, or Fourier's number, and that came out to 0.30876. From there, we calculated the dimensionless temperature. This calculation was the same for both potatoes, and the dimensionless temperature came out to 0.4912. From there, we used equation 9-12 for the sphere to back calculate A1 and lambda 1 to then get the BO number and then finally get the coefficient of convection. But as you can see from this equation, there's a problem. We have 2 unknowns and only 1 equation. To get another equation, we use table 9-1, specifically the sphere section, and we plugged in all the numbers for lambda and A1 into Excel, and then we plotted those numbers, X being lambda and Y being A, and from there we were able to get a formula. This formula related lambda and A1. We then substituted this formula into A1, and from there we were able to get 1 variable and 1 equation. We then plugged this equation into Desmos graphing calculator, went to where the line passed the y-axis, and that was our answer for lambda 1. We then were able to plug lambda 1 back into the equation to get A. We then took lambda 1 and A1 and used the equation seen on the bottom relating the BO number to lambda 1 and A1. This gave us a final BO number for the convection oven of 1.5903. Then rearranging the BI number equation for the coefficient of convection, we were able to get an answer of 25.04 watts per meter squared per degrees Kelvin. We then repeated the exact same steps for the air fryer. The only variable changing was the time, and the time for the air fryer was 54 minutes and 16 seconds, and this changed tau to 0.33645. The dimensionless temperature stayed the same at 0.4912. After using the equation gathered and plugging this new equation into Desmos, we got lambda 1 and A1, and then we're able to back calculate B1, which ended up being 1.3675. From there, we back calculated the coefficient of convection, and for the air fryer, we got 21.53 watts per meter squared per degree Kelvin. I believe these results are reasonable because after doing research and looking at what the coefficient of convection for most air fryers or convection ovens are, they typically range from 20 to 120 watts per meter squared per degrees Kelvin. So this could mean our air fryers / convection ovens are on the lower end of that, or our calculations could have been a little off, and it could actually be more or less. We believe some variables that might have affected the final outcome could have been the thermocouples not being in the very center of the potato, or the fact that the potatoes weren't the exact same size. Thank you for watching.